Hello friends, this video on direct and inverse proportion part 1 is brought to you by examfear.com. No more fear from exam. Topics to be covered in this lesson are introduction, direct proportion, inverse proportion, and problem solving using direct and inverse proportion. So what are we going to talk about in direct and inverse proportion? So let's look at this example to get a brief idea about what's all about this lesson. Okay, so let's say that you have this car and this car travels certain amount of distance in certain period of time. So let us assume that the speed of the car is uniform. That is, the car always travels with the same speed. Okay. Now let's say that the car traveled maybe 1 kilometer in 5 minutes, right? So let's make a note of these numbers. So in 5 minutes, the car covered 1 kilometer. Now let's say that in another 5 minutes, that is a total of 10 minutes now. So in 10 minutes, how much distance did the car cover? It covered 2 kilometers. Similarly, for 15 minutes, how much distance the car covered? It would have covered 3 kilometers. And so on. So basically what we are seeing is that as the time increases, the car covers more distance. Now, since the car is always traveling with the same speed, so there is no doubt that sometimes the car might travel fast, sometimes it might travel slow. So that possibility is ruled out. So the car is always traveling with the same speed. Now, more the time, if you ask the car to travel for 1 hour, it will cover more kilometers. If you ask the car to travel only for 5 minutes, it will cover less kilometers, right? So as the time increases, the distance also increases. So what do we understand from this? So considering speed is same, we find that as time increases, as t increases, what happens? The distance covered also increases. So t increases, d increases in such a way that the ratio of time to distance always remain constant. So that means if you look at these values, these are just some simpler values. You would see that the ratio is always the same in all the three cases. Whether you find out the ratio of distance by time or the ratio of time by distance, everywhere this ratio is the same. Right? So ratio of time to distance is 5:1 in all the three cases. So in this case, we say that time and distance, they are directly proportional to each other. That means as time increases, distance also increases. Similarly, as distance increases, time also increases. So this possibility holds true only when we assume that the vehicle is traveling with the uniform speed. Let us look at another example. Let's say that you went to a cloth shop and you want to buy some cloth. Maybe you want to get a dress stitched, and for that you need cloth. So now what happens? Let's say that you have many varieties of cloth in that store and you choose this particular variety of cloth. So now you will be telling the shopkeeper how much cloth do you need, what is the length of the cloth that you need. Now, how is the cost of the cloth dependent on the length of the cloth? Now, let's say that you say that you need 2 meters of cloth. So the cost of 2 meters is ₹100. So that's what the shopkeeper has told you. Now, suddenly you thought that no, I think 2 meters will not be sufficient. So I would need more. Right? So maybe you said that instead of 2, I need some 6 meters of cloth or some 4 meters of cloth. So what would be the cost of 6 meters of cloth? So 6 meters means you multiplied the initial 2 meters by 3. So basically you multiply it by 3. So therefore the cost also increases, right? Now the shopkeeper won't give you 6 meters of cloth for ₹100 because he gives 2 meters for 100. So 100 also will get multiplied by 3. So when you ask him for 6 meters, he would charge you ₹300. Similarly, if you ask him to give you 10 meters of cloth, what would be the cost? So the cost would also get multiplied because 10 meters means you will multiply the first one by 5. So 2 into 5 is 10. So therefore the cost of 2 meters was 100. So this would also get multiplied by 5. So for 10 meters, he would charge you rupees 500. So what are we saying? As the length of the cloth increases, the cost also increases. So that means length and cost. These are the two quantities which are directly proportional to each other. So in this case also, the ratio of the cost to the length remains constant at all times. For example, in the first case, if you look at the ratio of cost by length, then it is 100 by 2, which is equal to 50:1. In the second case, what is the ratio? It is 300 by 6, which is again equal to 50:1. In the third case, it is 500 by 10, which is again equal to 50:1. So the ratio of the cost to the length of the cloth remains constant at all instances. So here, this is another example where we see that two quantities, length and cost, are directly proportional to each other. Thank you. Please visit examfear.com for free quality education. You can learn with a simple 4-step learning process wherein you can watch video lessons, you can ask your questions, you can refer notes, and you can take a free online test. We have content for class 6 to 12 on physics, chemistry, mathematics, and biology along with practical videos. So please subscribe to our channel for daily updates. Thank you.